So, welcome to my talk, ladies and gentlemen. I'm really proud to be here. I'm from the Ruhr University in Bochum. I'm also working for CLICKJACKING and some other companies, but just as a small note. So, the topic of my talk is UI redressing attacks on Android devices. What I want to show you today is what UI redressing is in relation to mobile-based operating systems. This will be quite cool because at the end we will see a more or less 0 day that offers us as an attacker the chance to attack all Android systems. And this maybe for the next 5 years. So first of all, a few details about my person, which is maybe interesting for you. I'm working at the Horst Goetz Institute for IT Security, or to say it in German, at the Lehrstuhl für Netz- und Datensicherheit at the Ruhr University in Bochum. I'm doing my PhD there, and what I'm doing there and also doing my research is that I'm focusing on cross-site scripting attacks and countermeasures as well as UI redressing. And UI redressing is actually my passion. And thus I wrote a book about it in the last year at the D. Verlag from Heidelberg, which is quite nice. And this book is called CLICKJACKING and UI redressing. What a surprise. So if you're able to read something in German, yeah, I can really recommend it to buy it. So I'm also giving some security trainings and penetration tests. E.g. I'm working for the Deutsche Epos-Brief. And I also gave some talks in the past at conferences like the Blue Hat, this is the one from Microsoft in Redmond, Black Hat, German OWASP Day in Munich, and so on. And you can also find me on Twitter. So before I will show you the table of contents, I want to show you one note slide. The thing is that I wrote a paper for the Black Hat Abu Dhabi conference in December of the last year. And this paper includes, let me say, 90% of the research that I will present today. It's 7 pages long and it's free to download. So if you're interested in it, here is the link. The co-author is Jörg Schwenk. This is my professor from our chair of Network and Data Security. And this should be said. Okay, this is how the table of contents looks like. We will begin with a typical structure. First of all, an introduction. After that, I will show you some related work. So what did the security guys in the past? Then we will see how we can port existing UI redressing attacks to Android devices or other mobile devices. After that, I will introduce a more or less new browserless attack, which is the 0 day, if one can really say a 0 day to it, we will see. Then some mitigation techniques. So how can I prevent a user against being attacked on a desktop-based system, against being attacked on a mobile-based system, which includes the usage of browsers like Internet Explorer or Firefox. And how can one create mitigation techniques against our new browserless attack. Last but not least, there's a conclusion with an outlook where I will show you how my research or our research can affect the future or has already affected the future. So, the introduction part. And this is, by the way, the typical structure of the paper. So, we will see, as this displayed here, the related work, then porting, new browserless, which is sometimes confusing, but it's related to our paper and it makes much sense. Okay, so UI redressing is first of all a no problem since 2002. Why? Jesse Roderman posted in 2002 into the Mozilla bug tracker that it is possible to modify the Adobe Flash Player. And this led to the behavior that an attacker was able to control the microphone or the webcam of a victim, without any notice of his victim. And what Jesse wrote into the Mozilla bug tracker was, well guys, it is possible to make elements like iframes transparent. And in the case that we have, e.g. Amazon in an iframe, we can disable the white background and include this iframe into a web page which has, for example, a gray background. So we have evil.org with an iframe of Amazon.com, And Amazon has a gray background now because a white background is transparent in this case. And a victim could think, okay, I'm on Amazon, but he or she is actually on evil.org. Okay? So this problem was overlooked from the Mozilla bug tracker team or the Mozilla security team. And this led to our problem, which I described before with the Adobe Flash Player. This problem is called clickjacking and was founded by Robert Hansen and Jeremiah Grossman in 2008. So, clickjacking is today a part of a huge attack set, and this set is called UI redressing, so user interface redressing. And user interface redressing includes clickjacking, or the clickjacking attack from 2008, inside the clickjacking set, which is confusing because the clickjacking attack from 2008 is today called classic clickjacking. Okay, so we have UI redressing, clickjacking, and the attack from 2008, classic clickjacking inside the clickjacking subset. But this will be clearer in a few slides later. So what one can say from these attacks since 2008 is that all of these attacks need a web browser to be executed. Okay, so we need Firefox, Opera, Chrome, Internet Explorer, and so on. And what we want to show today is, can UI redressing attacks be ported to mobile-based systems like Android? Why Android, by the way? Well, I am focusing, or rather Jörg Schwenk and I am focusing on Android because of the market share situation. One can see it here quite nice. In the third quarter of 2010, the market share situation was not so good for Android because it was new, and Symbian from Nokia was more or less the number one from the market share. And this totally changed in the third quarter of 2011, and especially in the third quarter of 2012. Here we can see that Android has a market share of over 50%, and as it is written there, in November 2012, Android has a market share of 72.4%. And just for the Apple users, as I am, iOS has only a market share of 13.9% in November 2012, which isn't so much. So, okay, we are focusing on Android because of the market share situation, and on which version should we especially focus now? And we should focus, of course, on this version, so the version 2.3.3 till 2.3.7. This is a statistic from February 2012, which is today more or less the same. So most of the people are using the versions 2.1 to 2.3.7. So just to say it, this is the new version, Android 4.0, or new more or less, and the version which we are focusing on, Android 2.3.3. And just to say it, our 0 day at the end works on both versions. So from Android 2.3.1 to Android 4.0 and above. Just one sentence to the pictures. As we can see, we have a typical structure here. We have on the top a notification bar with the date or the clock. We have the Google search bar, to look up keywords. We have icons, like it is in this case. Okay, here's no icon, but this could be also there. And we have here some icons to open applications, like the phone call application, the contact data, the menu. This is here more or less the same. And of course, with the Earth symbol, the browser. So we can, if we control the home screen, open other applications directly, just to mention this. And I said that we are focusing on Android, but on which questions are we focusing on? Well, first of all, we are focusing on attacks and countermeasures for desktop-based browsers available for Android, as I said at the beginning. And we are focusing on a tabjacking attack, which is a part of clickjacking. which does not need a web browser to be executed. So it will not use a web browser, it will use an application from the Android market, or rather Google Play at this call now. Okay. Related work. So what did the security guys in the past? First of all, the desktop-based UI redressing techniques, and after that, the browserless UI redressing techniques. Well, the desktop-based, as I said, we have UI redressing as a set of attacks. And this set of attacks includes subsets like clickjacking, and we have other attacks like strokejacking, drag and drop operations, content extractions, event recycling, and SVG maskings. Well, I will show some demos in 3 minutes, but just to say that these attacks exist here. And when we zoom into the classic or clickjacking subset, we have things like classic clickjacking as a standalone attack. We have likejacking. This is an attack which is attacking Facebook, so the like button of Facebook. We have nested clickjacking and double clickjacking, academical attacks. We have cookie jacking and file jacking, event jacking, class jacking, cursor jacking, tab nabbing, combinations with CServe, cross-site scripting, and CSS. So you will think, well, Markus, what's going on CSS? CSS is actually cascading style sheets. This can't be right. And the thing is, CSS can also be used as an attack language like JavaScript, which is confusing, but you can look that up in a paper which is called Scriptless Attacks, Stealing the Pie Without Touching the Sill. Yeah, it is free to download. CSS, really interesting. So, okay. Maybe one explanation of classic clickjacking. So the Adobe Flash Player attack on Bing.com. And after that, the demos. So what we want to do is that we want to carry out a classic clickjacking attack now. As you can see, I'm on the Bing.com webpage, and I am logged in as Markus. You can see it at the bottom here, at the top here. So can you see my mouse cursor? Yeah, perfect. And what we want to attack is the sign out link. So we want that a victim will visit our page, and our page is, for example, evil.org. And by visiting this page and clicking on an element, the victim should be clicking on logout. So what we need is a valid session with Bing.com of the victim. So we target sign out. To use our attack, we need a little bit social engineering. And in this case, we have a headline here with funny pictures, 2 smileys, and a button. And this should be used to let a victim click on this button here. So most of the people will say, okay, when I click on click me, I will see some funny pictures like comics and so on. But this will not be the case. The victim will actually click on sign out here, okay? Good. So we have our social engineering page. Once again, the headline, the 2 smileys and the button. And our iframe. An iframe is more or less a small window which can load a website. And this frame or window can load Bing.com. And as we can see, when we load Bing.com here, we are also loading Bing.com in a session with a victim. So the victim is logged in into Bing.com here, as we can see it on Markus and sign out. What we need now is a little bit of CSS code. CSS code allows us to move our iframe to the top left of a web page so that the sign out link overlays the click me button here. And we also need a little bit of transparency, as we can see it on the left picture, because it's half transparent there and full transparent in the right case. Okay, and to understand it here a little bit clearer, this is the source code of the attack, nothing more. We have our h1 tag or element here with funny pictures. Well, then the smileys here, click me as a button, and our iframe element. And the magic behind clickjacking is the CSS code. There are some properties like position here, z-index to overlay the click me button, opacity, and filter alpha opacity is equal to 0, which gives us the transparency in this case. So opacity 0.0 means full transparency, 0.5 means half transparency. And when we say please move the element to the top left, and we say the iframe should have attributes like width and height, so that we can get this size here. Yeah, that's all. So we have an iframe which loads bing.com and overlays our button, nothing more. And after a click on Click Me, we will actually click, or by clicking on Click Me, we will actually click on Sign Out. And the best thing is the victim will not see it. So this is the attack from 2008. Now to browserless UI redressing attacks. The first question is here, is it possible to perform browser-like UI redressing attacks on mobile devices, which already exist? And to get some ideas about it, we need some knowledge about the existing attacks, of course. And this is the demo time now. So first of all, the cursor jacking attack, to give you a small impression about the easiest attack inside the click-jacking subset. So we have 4 links here. These are links with href elements, a tags, and href attributes are nothing special. When I click on 2, there will appear a window with 2. When I click on 1, there will appear a window with 1, and so on. So I click on 2, and here, click. I actually click on 1. So what happens here? I click on 1, and nothing happens. I click on 4, and I actually click on 3. Strange. The magic behind classic cursor jacking here is, here you can see it, that the mouse cursor is actually an image. And here is the background of our mouse cursor displayed in red. Before it was displayed in transparent, or it was transparent in this case. So we can see it here once again. If we click on 2, the top left of this image is on 1, so I click on 1. Yeah? So, and once again here, 4, I click on 3. And when I click on 1, nothing happens because there is no link to click on. Okay, so this is the easiest attack. We can also do some click-jacking stuff on div elements. Yeah, I hope it loads. No, it doesn't load. Okay. What can I show you then? Content extraction. Yeah, this is also click-jacking. This is drag and drop click-jacking. What I do here is that I want to drop or select a text and drop it into the text field here. So I will select this text now, click on it, and drop it into this text field. So the question is, first of all, what will I drop into this text field here? I actually drop me, but as we can see it here, I'm dropping malicious code. How can I do this? Well, first of all, I can drop a text which I actually have not selected. This is due to the reason that we are using HTML5 attributes here. I will show it to you with the source code. Here is the attribute draggable. We set it to true. Then we have an event handler on drag start. We set the MIME type, and then we say please drop malicious code. Yeah. So I'm using HTML5 here to drop something into the text field which I'm not really want to drop as a victim. And the other thing is that I can move values like a text from another website into another website, because this one here, this border is actually an iframe. We can show it here. So this is an iframe, which can be, for example, from evil.org. So we are on Amazon.org, can include an iframe with evil.org, and we are able to drag and drop text from Amazon to evil.org, which is quite awesome because of the same origin policy inside the web browser, this should not work. But this is a legal case in Firefox and other web browsers here, when we are using different windows or iframes in this case. So we can click on elements here by CLICKJACKING, and we actually click on another element, and we can change the behavior of, for example, drag and drop operations or values here. So once again to our question, is it possible to perform this kind of attacks on a mobile operating system without using a web browser? And the first idea was here from David Richardson in 2010. He analyzed Android, and what he said or wrote was that an application is to allow to programmatically open a dialog to interact with it. So this means that we as a developer can develop, for example, a computer game, and this computer game is able to open an application like the phone call application. Yeah? But what we are not able to do as a developer is that we cannot say, please call this number here. Yeah? We can just open the phone call application with a predefined number, nothing more. So we need the final touch gesture of a victim for this phone call. Or, e.g., we can open a web browser here which opens a URL, but we cannot navigate with this web browser here as a normal application with no rights. This is important to say, with no rights. Yeah? So once again, an application is allowed to programmatically open a dialog, but not to interact with it. This is very important for our attack. So the next idea was based on this message that one can use a toast view. What is a toast view? A toast view is more or less a notification message. And this notification message can say, hey, you have changed the volume of your device. So you can make it louder or a little bit more silent. And in this case, I used my mobile device to make it a little bit louder. And this message appears, and the important thing is that I can type on or touch on this message, and after touching on this message, when I touch it here, I will actually touch the Google search bar. So it lets touch gestures under my application or under my notification. Yeah? It's more or less totally transparent. Yeah? So the next idea was from Jack Manino, I'm hoping that I'm spelling it right here, is that we can scale such notification messages. And scaling this message, in this case, scaling can be used to make it full screen. So we have this small one here, make it full screen, and thus we are able to have a notification which overlays the home screen. Yeah? So the crucial point here is that, and I said this once again here, a touch gesture on such a message or notification will be passed through to the underlying application. So I can touch on the notification, I will actually touch on the home screen here. So what we as an attacker can do now is that we can design a notification message which looks like an application, like this one here. This can be, for example, a screenshot. And what we as a victim will do is to click or touch on go, but we are actually touch another application with the same button, which is, for example, yes. Yeah? And this is the real application, and this is the notification. This is not an application in this case. Yeah? So this to the related work part. So we saw that we have UI redressing attacks. And we also saw that there are UI redressing attacks possible on Android devices. So now to porting UI redressing to Android devices, to be more, or to go more into detail. Well, classic clickjacking is the keyword here, or rather clickjacking. One can say that most of the clickjacking attacks are working on Android because nearly all browsers are available under Android, like Internet Explorer, Chrome. We have, okay, Safari is not the case, but Safari has the same engine as Chrome. We have Opera, yeah? What we don't have is Internet Explorer. And this is the case why some attacks like cookie jacking are not working, because cookie jacking is the only attack which is based on Internet Explorer. But most of us attacks can be carried out due to the available browser versions. So we have more or less the same issues. What we can also carry out is, for example, cursor jacking. Why? Because we do not have a cursor on a mobile device. Yeah? So now to the new browserless attacks part. So what I told you was that Jack was able to create a notification which was displayed over the whole screen. Yeah. And this is what I didn't say. He was able to show it for a longer time because a notification is only displayed for, in most of the cases, 3 seconds, or 2 to 3 seconds. And what he was able to do is to show it for a longer time, like, for example, 60 seconds or 2 minutes. Yeah? So it's more or less bad in the case because he was able to create a notification which overlays an application and which looks like a normal application in this case. Yeah? But the scope of Jack, and this is what we did, was too focused on, for example, phone calls, or too focused on the home screen itself, or on some applications on the home screen. What we found out is that the scope of this attack is a little bit wider because we can manipulate the contact data, we can use the web browser to navigate to a website which we as an attacker define. We can log touch gestures on a system, so wherever you touch on your display, we can log this without having any privileges for this. This is really important to say. We can use the phone call application to do predefined phone calls, and this was also possible in the past. We could install applications in the background with the help of the Android market. Yeah? So I will show you, by the way, a demo in 2 minutes. All of these attacks are using the same technique once again. First of all, there is a visible attacker's application in form of a notification in the foreground. So we are going to the Android market or Google Play and downloading a computer game, for example. And this computer game has no rights. So this computer game cannot do a phone call, it cannot write SMS, it cannot get access to your contact data. But this is possible with our attack. Yeah? And this is possible because there is an application in the background like the phone call application. So let us see this in a demo. Good. So we have the Android emulator here, which is a little bit slow, which also shows that it is really an emulator. And we are using the version 2.1 here. But this works on all Android versions, just to say it, yeah? So it's booting. Yeah. Here it is. So we have our home screen here. I will use the lock and unlock it. And we have our application, which can be downloaded from the Android market. And once again, it has no rights. So we can do actually nothing. But what we can do, we can use tab checking here. So we introduced the tag. Let's do this attack with a dialer or with a phone call application. So we have a notification in this case, and we as a victim think, okay, I will click on go for it, because I should not press it. And look at the top left, there appears a phone call icon. Yeah? And once again, this application has no rights to do a phone call. And what number are we calling here? We are calling the number 1337, 1337. So, and now we attack with a transparent background, not with a white background. So we have a transparent background here. We can see that there is the phone call application with a predefined number, and all what we need is a touch gesture on the phone call icon, which is under go for it. That's all. Yeah? So we can open applications behind other applications, and this application from us as an attacker is just a notification, nothing more. Yeah? And this notification looks like a normal application. Yeah. So just once again, we are clicking here on this nice button, and here's the phone call. Good. So this is basically the attack. The thing is, and this is also something which one should think about, that there is a limited number of operations which one can do, because all what we do here is to call an application with action underscore and then a name, and this name can be, for example, phone, to open the phone call application. But there is a limited number of I think 15 applications which does not allow us to do not allow us to control the whole mobile device. Yeah? It just allows us as an attacker to control the phone call application here, or the contact data, or the web browser, yeah? But not the whole device, as I said. The solution for this as an attacker is that one can directly access the home screen here. So we do not need an application in the background. We can use the home screen to navigate to the menu bar. We can say, go to settings, change a password, or change a setting of a mobile device, and so on. But what we need here are more than one touch gesture. Yeah? So we need a few of them, and this is a little bit complicated in real-life attacks. But this is also possible. We can also attack the home screen here. So we saw some attacks and we saw some mitigation techniques. Now to the mitigation or countermeasures. First of all, browser-based to hold the structure of a paper, and then one countermeasure against tab-jacking. So the attack with a phone call application. Browser-based UI redressing. So what can we do to prevent a victim against being attacked under a web browser? So against being attacked by, for example, classic clickjacking, as we saw it with the Bing.com attack. Well, first of all, we can use framebusters. Framebusters is a piece of JavaScript code which controls if a website is loaded in a frame. So let us name an example. We are evil.org, and we have PayPal.org, which we want to frame, so want to load inside an iframe. And PayPal.org has such a framebuster here, which could be the case in the past, who knows. And what PayPal did was, or maybe did, was that they checked, is the top location not equal to the location? Which means, is PayPal loaded in a frame? Is PayPal loaded in a frame which is not from PayPal.org, or which is, for example, evil.org, as it is in the case of the attack? So if it is loaded in a frame and not from PayPal.org, then it jumps to top location is equal to self location, which means the frame will be busted. So the URL of our browser tab will change from evil.org to paper.org because we want to attack paper.org. Yeah? So that's all. This kind of frame busting attack can be attacked by busting frame busting techniques. These techniques are using, for example, the cross-site scripting filter of Internet Explorer or the Chrome cross-site scripting filter, which is the XSS auditor. Yeah? There are different techniques to stop the execution of this kind of attacks, and thus this attack is not real. This countermeasure is not really attack resistant. And based on this idea, more or less, there is developed another frame buster with a little bit CSS code, and this is the most resistant one, which I want to show you and which I can really recommend. The thing here is that a victim, or rather a normal user who is loading, let me say paper once again, which is loading the paper web page, will not see the whole body because of a CSS code. So we have here CSS, and we say the body should have the CSS property display with a value known. So it should be invisible per default. And then we have a JavaScript code here with our frame buster, but the frame buster is a little bit different because it checks if the self location is equal to the top location. So is papal.org just framed by papal.org, or isn't there a frame? And if this is the case, so if everything is okay, then we say document.getElementById anti-clickjacking, which is here, yeah, and then we have a reference there and say parent node remove child anti-clickjack. So we remove the display known value here. If we are under an attack, then we have our frame buster, so top location is equal to safe location as it is displayed here. Yeah? So the crucial thing here, or the important thing here is, if we are under attack, there are two options. The first option is that the frame will be busted, which is really, really good. But if JavaScript code is disabled, so if we we have no chance to execute this because of a frame busting attack, we as a victim will not see the whole body, and thus we cannot use the web page. You know, and therefore an attack is not possible anymore. So this is a quite nice attack, or rather countermeasure. So, okay, another countermeasure is an HTTP header, which is Xframe options. Xframe options is an HTTP header developed by Microsoft in 2008, and it can have one of these three values. The first is deny, then same origin, and then allow from origin. Deny means that no web page is allowed to frame me. So if we are Amazon and we have Xframe options deny, then Amazon.org cannot frame Amazon. Yeah? And also evil.org cannot frame Amazon.com. If we say same origin, then Amazon.org is allowed to frame Amazon.org, but evil.org isn't allowed to frame Amazon. Yeah? And allow from origin can be used to define a valid URL where origin is, and then we can say, for example, google.com should be allowed to frame google.de. So then this will work if google.de has this header, so Xframe options, double point, allow from http google.com. Yeah? If we are google.de. The point is here that this header is more or less new because it was founded in 2008. And we can see it here. It is just supported in Firefox 3.6.9 and above, Opera 10.5 and above, and IE 8 and above. So I know many, many users who are using IE 6 and IE 7, so this is no good countermeasure for them. Another countermeasure is the content security policy. Who of you knows what the content security policy is? No one? Really? Okay. Okay, so the content security policy is also an HTTP header which can be read up in the W3C draft. And the content security policy defines if a web page can load resources from another web page. So we can say, I am Amazon and I am using the content security policy, and I say that only Flickr is allowed to include images on my website, and only Amazon is allowed to include images on my website, and not attackers.org. Yeah? So I can define the resources here, or where the resources can come from. There are two CSPs, an old and a new one. The old one had two aims. The first aim was to prevent a victim against cross-site scripting attacks, and the other aim was to prevent a victim against UI redressing attacks. And this changed because this was too complex. Twitter implemented it a few years ago, but this wasn't so useful, and as I said, very, very complex. Thus they developed a new CSP. The thing is that, you can see it here, the CSP isn't well supported in the current web browsers on mobile devices. It is supported on Chrome in nearly 100%, and it is nearly full supported in Firefox, but just in the new version on the desktop. Yeah? What we can say on mobile devices is that just the old CSP, and this is the CSP which isn't defined in the W3C draft anymore, is supported by Firefox 4.0.3 and above. Yeah? And the new CSP isn't supported by any browser. But it will be, hopefully. XM options is supported by any browser, just to say it. Yeah? When we are zooming into the content security policy, then we have two ways to define it. And the first way is to use the X minus content security policy, CSP is just an abbreviation here, to use it. And as we can see it here, the top 100,000 web pages of the world from Alexa.com, which is a statistic web page with website ranks, we can see that only 3 of the web pages are using X minus content security policy. From the top 500,000, 9 web pages, and from the top 1 million, 18 web pages. So not so much, but some of them are using it. And X minus WebKit CSP is, of course, a header from WebKit, so Chrome and Safari, and there's just one web page which supports it or includes it. Maybe Apple, who knows? Yeah. Okay, so we know that there is a framebuster as a countermeasure against browser-based attacks on mobile devices. We know that we have XM options as an HTTP header, and we know that we have the content security policy as an HTTP header. Good. This should be actually enough for us, but we have also a countermeasure, or maybe a countermeasure, against our tab checking attack. So the phone call attack or home screen attack here. Well, to be honest, there are actually more than one countermeasures, but this countermeasure is more or less unuseful for us. We will see why. Well, the first countermeasure was from Google, by the way, to give a developer the chance to protect his own application against being attacked. So let's imagine the case that an application from Deutsche Bank has an option to make online transactions. And what Deutsche Bank can do here is that we say if a victim or if a user is click or touching on a transaction or make the transaction or order something from the stock market, then the button or element can have one of these attributes here or methods. set filter touch has been obscured or Android filter touch has been obscured. This means that no notification message is allowed over this application, or rather no touch gesture on an application with a notification is allowed over my application from Deutsche Bank in this case. Yeah? The point is that this countermeasure is actually one because the method and the attribute here is more or less the same, was introduced with Android 2.2. But applications like the phone call application do not use it. So they introduce a countermeasure which is more or less unuseful for us because we can attack a victim with, for example, the phone call application. And this is, by the way, the reason why this attack will be a 0-day in the next 5 years, because the people are buying mobile phones today with an Android version of 2.0 or 2.3.7, and Google will not upgrade your device, and thus you can attack your phone call anytime, or the phone call application anytime. Our idea was the following. We want to introduce a tab-jacking security layer, a TSL, yeah? And this layer consists of more or less one button. And this button is using the attribute from the last slide here. So it is using Android filter touch has been obscured. So whenever there is a notification, it will be blocked with our layer, and thus the application behind it, like the phone call application, cannot be attacked anymore. The point is that a layer can be set here and not behind the notification. The notification is every time on the top. And thus, the countermeasure can only be implemented by the Android developers, which isn't the case right now. Maybe in the future. So, conclusion and outlook. We saw that most of the existing UI redressing attacks can be used with very little effort. Just some of them do not work, like cookie jacking and cursor jacking. There are a lot of countermeasures for desktop-based browsers and mobile-based browsers, like Firefox, Chrome, and Opera. Framebuster is the keyword here. We have Xframe options as an HTTP header, and the content security policy. And what we also saw is that it is possible to attack applications with another application which has no rights for making, e.g., phone calls. Yeah? What we must recommend to a vendor or developer team like Google is to implement our TLS, because in my opinion it is really important to have such a countermeasure. And the final sentence is here that I think that HTML5 and CSS3 will give us as an attacker the chance to carry out many attacks which will maybe make the situation even worse in the future. Yeah, like it is in the case of file jacking, or we saw the drag and drop attack with draggable as an attribute here. So that was it. Thank you for your attention, and if you have any questions, feel free to ask me. What's in here?
Questions.
Questions. No question?
Did you speak with Google?
Yeah. I wrote them some mails, but the response was that they are more or less not interested in it. But yeah, we will see that in future, maybe. Maybe it will be implemented, but I don't know. So, by the way, one question for you. Who thinks that iOS, so the operating system of Apple, can be also attacked with tab jacking? Hands up or not? No hands? You? Okay. Why? Do you have an idea? Hard to say, yeah. The thing is, iOS cannot be attacked because you have to allow each application to, for example, show push messages. Yeah? So you install an application, the application wants to send you some push messages, and you have explicitly to click on OK to allow this. Yeah? So this does not work in iOS here, the notification attack, just to say it. Yeah? So Apple is actually not so bad in this case, but just in this case.
And what about Windows Phone 8?
I don't know. Yeah. Yeah, no experience with it.
Other questions? So, thank you, Markus,
Okay.
for your
Thank you.
interesting talk, and for the demos. Thank you.
Yeah, thank you.